So hi everyone. So today I'm going to talk about this wideband study of FRB 2024-0114A with the uGMRT and VLA. Let's get a brief idea of what hyperactive repeaters are. So we have there was a very nice overview given by Laura previously for repeating FRBs. So hyperactive repeaters are basically repeaters which are highly active over a duration of, let's say, weeks or months or sometimes even years. And these are some of the repeating FRBs which provide us with large sample of bursts which we can study in detail. They provide us with you can do a host of analysis, and it's a complementary approach. Like we are building up large samples of FRBs to basically look we are building up large samples to study host galaxies and those things to identify their progenitors. But this is just a complementary approach where you can identify more about their progenitors and even emission mechanisms. And so one such hyperactive repeater, which previously Manisha and Laura have already talked about, which I will be talking also, is FRB 2024-0114A. So I'll give a brief timeline of this FRB. So it was basically detected by Chime FRB collaboration at a DM of 521.7 parsec per centimeter cube. And the interesting thing to note about this FRB is that this was actually quite far from the zenith of the Chime site. So it had a very short exposure time, which is basically about 4 minutes for Chime. Despite that, they actually detected this very two bright burst in a span of just 4 days. And this prompted us that at sensitivities of, say, Jansky millisecond, we would have very high burst rates. And this was later confirmed with several follow-ups by different telescopes like Parkes, FAST, and our own observations with GMRT. And this was basically active for a large frequency range from 300 to even detections at S-band. And later the host galaxy, the redshift from the host galaxy was also identified to be about 0.13. So let's move on to the follow-up observations with GMRT. So we did a very prompt observations with GMRT on 1st of Feb 2024, and we detected about 5 bursts in the IA beam, but not in the PA beam, which meant, so to give prior to this, basically Chime provides a position which has a at least an arc minute of uncertainty. So it's not very well localized. So that is also what was inferred from our these detections. So we were trying to localize this. However, at that time we had the visibility resolution of 0.67 seconds with the GMRT. Had we have a spotlight backend, then we would have been able to localize that. But later on, Meerkat was able to localize this to an arc second precision. And from there, we were able to carry out sensitive PA observations later on with the GMRT. And then we followed up initially with band 3. And then later, we also had observations with band 4. There is one nice example I've shown with this burst, which has 2 components. And there is a nice drifting pattern as well in this. So in total, we detected about 53 bursts in band 3 and 122 detections in band 4. And luckily in our observations, we had a nearly coincident observations with FAST, and they had reported a burst storm that was there on 5th of March 2024. And the interesting thing to note about is that this had a burst rate of about 500 bursts per hour or in excess of that. And we also detected the same kind of elevated burst rate, around 31 bursts per hour at 400 megahertz. But that was when we tried to basically scale using a fiducial power law index of minus 1.5. We saw that the burst rate was not as expected as would have been at 400 megahertz, keeping in mind the burst rate detected by the FAST. So this meant that there was a burst rate had a frequency dependence. So for all the bursts, we were able to characterize the burst spectra, and we basically determined for each of the burst, the peak frequency and the emission bandwidth. And on the left, what you see here is this the plot for the band 3 bursts, where you can see that basically the bursts are basically clustered over the upper half of the band, and it's most likely the effect of narrow band RFI in the lower part of the band, and that's why we are. But if you see at band 4, these bursts are basically clustered. The peak frequency of the burst is basically uniformly clustered over the band. Only it falls near the edges of the band, which is expected. If we talk about the fractional bandwidth, which is delta nu by nu, which has been to characterize the narrow band emission, and this generally peaks around 10% at band 3 and also at about 13% at band 4, and this kind of behavior has been seen in many of the previously with magnetars like XT1810, and then with giant pulses of crab. So this kind of behavior suggests that the origin could be something which has a high magnetic field. Similarly, for some of the bursts, we were also able to measure the drift rates, which had well separated components, drifting components. And in 2022, Wang et al. Basically gave a empirical, like a model where you would have emission coming out at different heights of the magnetosphere of a magnetar, where this drifting components will come at from the emission from the different heights. And in this parameter space, if you see this, mostly the points were filled up over the higher frequency range. So only there were 2 points earlier, which were from the R3, FRB 2018-0916B. And so our points also populated this lower frequency space. And this also, again, lends support towards magnetospheric origin of the repeating FRBs. To also infer more about the emission mechanism of FRBs, you look at the energetics of the burst, and to look at the energetics, you basically draw a cumulative distribution of energies of the burst, and here we use the frequencies as the proxy. If you see, we could fit this cumulative distribution with a single power law, and the power law is about -1.24, which is well within the range of what we see in different repeaters, and these are also seen for giant pulses of crab and magnetars. And this is for band 3, and similarly for band 4 also, we also see this similar kind of single power law fit with a power law index of -1.4, which is basically again within that range. And here we also take into account the completeness of a sample. So one interesting thing, we noted that initially when the FRB was detected, it was hyperactive, and there are a lot of telescopes which are following up. So we collected some information from different ETLs that were published, from January 2024 when it was discovered to April 2024. And what we see is that initially the bursts that were reported were at lower frequencies, which range from 0.3 to 2.2 gigahertz, but there were no detections at higher frequencies. But later on, we saw that there were detections even at S band and C band. So this like the activity, high activity, or you can say the normal activity that arrives for higher frequencies is contrary to what we see in 2018-0916B. So where high activity actually arrives for higher activity first. So this is in contrast to that, and this was an interesting thing we saw. But there is one caveat to here, is that there is a lack of sub-band searches over higher frequencies, and this could have led to possible non-detections. So we were now following up this source with VLA as well, and we were looking at the spectra of the PRS associated with it. So we had observations in S band, C band, and X band. So we actually detected the PRS emission. So here this plot is from the C band, and this one is from X band. And the flux density is about like 80 microjansky here in C band and 82 in X band, which is like very similar to what was detected at lower bands. However, did not detect anything at S-band. So this work is a little bit preliminary. So we are doing ongoing, like the analysis is still going on. So we might detect source as S-band also. And what seems like from here is that the spectra is relatively flat, which has also been observed for well-known PRSs associated with FRB 2020-12 1102A and FRB 2019-0520B. We also have detected the PRS with uGMRT observations at 650 megahertz as well. So you will hear more about this in Yash's talk. So something interesting I want to show here is that some of our observations actually detected burst in the S-band with the real fast backend with the VLA. And these bursts basically are also showing this kind of narrow band emission, which also Laura was also showing that they don't occupy the full band, and this is mostly close to like 2.6 or 2.7 gigahertz where the central frequency lies. And similarly, all the other bursts also like show the similar kind of occupation of the band. Yeah, so this is still going on. I'm also characterizing how the burst properties will look like for these bursts. Yeah, so finally, I'll just leave out with sub comments and summary. So this has been a very highly active hyper repeater. So if you like been following up with the FRB 2025 and even in this conference, there are a lot of talks on this FRB, and this has like with at least what I know is from FAST, they have detected about more than 10,000 bursts. And this FRB is basically raising the question whether the energy budget problem, where if we consider just the dipolar, magnetic dipolar energy of the magnetar, so with the FAST, they show that there is about like 86% of the, like if you calculate the isotropic energy of the burst, all the bursts detected, it's about 86%. And if you consider even all the bursts detected at different frequencies, it would be even more. So it likely hints that this is just not, the emission is just not powered by the magnetic energy, and there has to be some other energy source as well. Another question that we can ask here is that, do all the active repeaters show this burst storms? And there have been few FRBs which show this. So, and then there is another really important question that we should address is the narrowband emission, whether this is really interesting to the source or it's likely due to propagation effects, and arguments have been put forward for both. And what we are seeing is that most, like most active repeaters, we are seeing this, there is many observational properties that are similar. So this could be that they have shared emission mechanisms. And another thing is that this source, like the fourth repeating FRB out of 5, which have persistent radius source associated with them. Yeah, so thanks.
Thank you, Ajay. Questions, comments for Ajay? Are there any questions from Zoom participants?
Yep. Hi, nice talk, Ajay. A very noob question. When you talk about burst storm, do you have any empirical formula, like when you characterize that a repeater is having burst storm, like certain number of read per hour?
So, like there is no characteristic as such, but what happens is that you see a very, like a few, at least some, like at least an order of magnitude of higher burst rate than the baseline levels. That's when, that's how you identify that it's a burst storm. Like there have been cases like, if you see this, the same, which I was talking about, like fast, it has usually had a burst rate or like around 100 bursts per hour. So it basically rose up to about, like they have reported also now that there are, it was about like 700 bursts per hour for that. Then there is one which is associated with FRB 2020, if I naming it correct, 0114A. So there was a paper by Kenzie Nemo where they had this burst rate, which was not very high. Like it was around 21 bursts per hour or something like of that number. But the baseline level is very low, like maybe few bursts just for an hour. It depends on what kind of FRB you're looking at. So it has to be very higher than the base activity level.
Okay, that makes sense. Another follow-up question. Do storm dies down? I mean, you have burst storm and then do you see after a while there's a slope, it's dying down, the burst rates go below certain,
Yes.
and then they rise up again?
Yeah, so that characterization, I think we have not looked at, and even other papers have not, like nobody has looked at really at characterizing like what, like how it dies, like what is the time, like time scale, how it rises. That kind of like study would be interesting, and this could also have some implications on the progenitors.
Yep. Thanks.
Okay, any more questions? Yeah, there.
Yeah, hi Ajay. Just wanted to ask you on the frequency dependent activity, your data, is it limited to last year or do you have additional data from this year that indicates the same thing?
Yeah. So that was from the last year, and I think for this year, like I've been recently I think two papers have come out from, especially with I think Effelsberg observations were detected S-band, and then there was also a lot of detections with Parks, so Utarkar et al. There, so they are also looking at that. So I think there is a little bit support on towards that, but I'm not really sure like if that's the case that we are seeing now also.
Any more questions? If not, let us thank the speaker once again.